Ah, hello. I didn't see you guys there. Today we're going to talk about cell potential.
Cell potential is a measure of the difference between two half cells' abilities to transfer electrons. And to help find cell potential, we will use this here electrochemical cell to demonstrate. Here we have one half cell that consists of copper, and we have another half cell here that consists of silver. And as we can tell by the diagram already, electrons transfer from copper and make their way to the silver. Through that, we can determine that silver is the cathode and that copper is the anode, which we will eventually use come time of calculation for cell potential. The voltmeter here reads 1.14 volts, which is actually the cell potential. The first step towards finding how the voltmeter read that requires writing the actual redox reaction that occurs here in the picture.
So here we have a list of the common half reactions we use to find standard reduction potential and cell potential. So to find cell potential for our redox equation, we must find the half reactions most relevant to the redox reaction. So right off the bat, we can find Ag plus an E minus yields Ag neutral. And there is no half reaction on this list that matches the Cu yields Cu2 plus, but we can find the exact opposite, which is no problem. We can use that as long as we remember to flip the value of the standard reduction potential listed here. So for our redox equation that includes Cu yields Cu2 plus, instead of positive 0.34, we would have a negative 0.34. So, using the chart, we were able to determine that the standard reduction potential of Ag plus is 0.80 volts, and the standard reduction potential of copper is negative 0.34 volts. The formula for finding the cell potential is cell potential equals standard reduction potential of the cathode minus standard reduction potential of the anode. We remember that the cathode is always the more positive one and that the anode is the more negative one. It doesn't always imply that the anode is negative, but it is just less than the cathode. And with that said, not only according to the list, also according to the picture that we had earlier, we were able to determine that silver plus was the cathode and that copper was the anode. And with the standard reduction potentials listed, we will put that the cell potential equals 0.80 minus negative 0.34, meaning our cell potential is 1.14 volts, which is exactly what our voltmeter in the diagram says. Just some quick notes about cell potential. It helps to remember that it'll always be positive. If you take a higher value and subtract it by a lower value, no matter what, it'll always be positive. If you ever get a negative value, you know you're doing it wrong. If you're ever going to do anything in free response questions regarding cell potential, it is important that you do list this here equation. Maybe you can get some credit for it, or you can at least remember to do it right by including it.
How do I stop it? Well, that's everything you need to know about cell potential and standard reduction potential. Good luck on the AP exam. And if you excuse me, I have a world to save. Meow, 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 meow.